What if your research assistant didn't guess the answer, but looked it up? In the next 10 minutes, you'll build a real AI agent in Python that does exactly that. Welcome to Multiome Academy. This is building your first AI agent. By the end of this video, you'll understand exactly how an AI agent works, line by line, and you'll have a working research assistant that looks up genes and searches scientific literature instead of guessing from memory. Strip away the hype, and an agent is three things working together. A language model that can reason about a task and decide what to do next. A set of tools it's allowed to use, plain functions that search databases or call APIs. And a loop that keeps the conversation going between the model and the tools until the task is done. A chatbot answers from memory. An agent decides it needs current information, calls a tool, and reads the result before answering. Here's a mental model that makes this click. The language model is a capable colleague with no internet access and no hands, and tools are the hands you give it. A chatbot generates one response from training data, no live data, no second attempt. A pipeline executes steps you ordered in advance. Reliable, precisely because nothing decides anything at runtime. An agent sits between the two. You fix the tools and the safety limits, and the model chooses the sequence at runtime, reacting to what each tool actually returns. Here is the flow every agent framework in existence is a dressed-up version of. Send the user's question to the model, along with descriptions of the available tools. The model responds, either with an answer or by saying, I want to call this tool with these arguments. If it requested a tool, your code runs the real function and sends the result back. The model reads that result and either answers or requests another tool call. You repeat this until the model produces a final answer, or you hit a safety limit. Today we're building a human gene annotation and literature assistant. Ask it something like, what does the GFAP gene do, and which chromosome is it on in GRCH38? Lookup_gene calls MyGene.info for real annotation data. Name, summary, GRCH38 coordinates. Search_PubMed calls NCBI's utilities for recent papers, abstracts, and citations. And one honest note, general gene annotation can't tell you about tissue expression or cell type specificity. A good agent is explicit about what its tools can and cannot prove. Setup is almost nothing. You need Python 3.9 or later and an API key. Install the Anthropic client and the requests library. Then set your API key as an environment variable. No agent framework, no vector database. Once you understand the raw loop, frameworks become easy to evaluate. An agent tool starts life as an ordinary function. Define lookup_gene, taking a gene symbol, and normalize it, strip whitespace, and uppercase it. Query MyGene.info, a free public API, for the human record matching that symbol. Ask for the fields you need, and pull the matching hits back out of the response. If there are no hits, return a clear error instead of guessing. Otherwise, return the top hit. Test this on its own, before any AI is involved. If it works standalone, half your agent is already done. Here's a subtle trap to avoid. MyGene returns hits ranked by relevance score, and taking the first result doesn't guarantee an exact match. The fix is one line. Verify the return symbol matches what you asked for before trusting the result. Query a typo or a retired alias, and you can silently get a different gene back with a perfectly plausible-looking annotation. That's why it matters. One detail matters more than any other. The model is completely stateless between API calls. It only knows what's in the messages list you send it. First, append the model's own response. That's the object carrying its tool request. Then append a matching tool result in the very next message. Skip either one, and the model has no record it ever asked for the tool, so it asks again. Forever. If your agent seems stuck in a loop, inspect the message history first. The model cannot read your Python source. It only sees a JSON description you provide. Name the tool, and start describing it. State when to use it, not just what it does. Say clearly, Use this whenever the user asks about a specific gene rather than answering from memory. Close the description and define the input schema. The only parameter here is the symbol. Mark it required. This description is effectively a tiny prompt, and its quality decides whether the model uses the tool correctly. Here's the single most common beginner bug. Not every response is a finished answer. End_turn means the model actually finished, the only value where you should use the text as is. Tool_use means it wants to call a tool. Run it, and loop again. Max_tokens means the response was cut off mid-sentence. Return that as an answer, and you silently ship truncated text. And refusal means the model declined. Surface that honestly. Check stop_reason explicitly every single time. Now the core of the agent. Read this slowly. Everything else in the agent world is a variation on it. Call the model inside a loop with a turn limit. If it finished naturally, return the answer. If it wants a tool instead, append the model's own request to the message history first. Then run each tool it asked for, and append every result right back into that same list. The model is stateless between calls. It only knows what's in that message history. Forget to append the result, and it asks for the same data forever. Run it. First, the trace shows the command that started the agent. The model calls lookup_gene for GFAP. Then, unprompted, it also calls search_PubMed for recent literature. Now it starts writing the answer, grounded in that first tool's data, walking through the gene's function and location, down to the exact GRCH38 coordinates, and closing with the paper's PubMed just returned. Nobody scripted that second tool call. The model decided it needed literature too, and planned that sequence itself. The literature tool queries NCBI's e-utilities. Sort by publication date for recent paper questions. Identify your application with tool and email parameters, as NCBI's usage policy asks. And titles alone aren't enough to summarize what a paper found. You need the abstract too, fetched with a second call called eFetch. Building the happy path takes an afternoon. What separates a toy from a tool is how it handles failure, and failures follow a pattern: symptom, cause, fix. If the model skips your tool and answers from memory, strengthen the description, or force the call with Anthropic's tool_choice parameter. If a tool throws an exception, catch it and return the error as data. Mark it is_error true, so the model can recover instead of the whole conversation crashing. If arguments are malformed, validate inside your function and return a message the model can actually read and self-correct from. And cap both turns and total tool calls, because one response can request several tools at once, and a confused model can loop far longer and far more expensively than you'd expect. You now have the complete skeleton and every advanced capability slots in somewhere. Memory is just managing that messages list across sessions. Retrieval augmented generation is a tool that searches your own documents. The loop doesn't change. Want tissue-specific evidence? Add the Allen Brain Atlas or CLLXGNE as a new tool. And now that you've written the raw loop by hand, you can open a framework like LangGraph and see exactly which of your functions each feature replaces. Let's recap the clear path. Write plain, well-tested functions first, describe them precisely, wrap them in a loop with a turn limit, and return errors as data so the model can recover. The mystique around agents evaporates once you see the whole field rests on one honest idea. Give a reasoning model some functions and the patience to let it use them. The full interactive tutorial and a hardened copy-and-run companion script are linked below at Multiome Academy. Thanks for watching. Now go build something that looks things up.